Hi guys, this is Mrs. Kamenar. We're going to take a look at topic 5.6, tangent, secants, and angle measures. Now this is going to line up with the reveal pilot that we were trying out before we went to our virtual learning sessions. So if you want to follow along with the website, that's been linked on Blackboard as well. Otherwise, you can just take a look at our notes. The essential question for today, just like we've been dealing with so far in the unit, is how can I solve for measures in circles? We're going to start out with a new vocabulary term, and our new term is a secant. And this is a line or array that's going to intersect the circle in exactly 2 points. So if I want to draw out my secant, I will just have any old line or array, and it's going to cross the circle in 2 spots. That's my secant. Now, if you remember from last week, we also talked about a tangent, and with tangent we're just thinking touch. So if I have another circle and it just touches in one spot, that is my tangent. We're going to focus in on tangents and secants today. Alright, so we have 3 theorems to go through, and the first one is 1014, and it says if 2 secants or chords intersect in the interior of a circle, then the measure of each angle is formed is 1/2 the sum, and let's highlight that word sum, of the measures of the arcs intercepted by the angle and its vertical angle. Alright, so let's take a look. So down here in this diagram, we have secants AC and BD. Alright, and you'll notice that we're talking about angle 1 here hanging out. And if I'm looking at angle 1, I see that I have this top orange angle, or arc, and this bottom orange arc. And if I want to find the measure of angle 1, it's going to be equal to 1/2 of AB plus DC. So if this guy here was 100 degrees, and this one here was 120 degrees, I would add them up and multiply by 1/2, or divide by 2, to get the measure of angle 1. Okay. If I want to look at it in a different way, this time looking at angle number 2, notice that angle number 2, those secants are hugging around the green arc AD and the green arc BC. So if I want to find the measure of angle 2, I'm going to figure out the measure for arc AD and the measure of arc BD, add them up and divide by 2. So if I have 40 and 50 degrees hanging out here, to find the measure of angle 2, 40 plus 50, divide by 2 to find the measure of angle 2. Alright, cruising along. Looking at theorem 1015, it says if a secant and a tangent intersect at a point of tangency, the measure of each angle formed is 1/2 the measure of the intercepted arc. Alright, so let's take a look here. If we're looking at this orange arc that's been that's hanging out at AB, we'll notice that we have this tangent guy and a secant, and it's kind of splitting off the measure of arc AB. So my measure of angle 1 is going to be equal to 1/2 the measure of arc AB. It might be easier to visualize if we come up with a more common situation. So we have a circle, we have our tangent, and let's say that this secant here divides our circle into 1/2. So if this arc here was 180 degrees, I can divide by 2 to get this 90-degree angle. All right. Looking at the other half of the circle, if we want to look at angle 2, okay, so angle 2 marks off that arc, that major arc ACB, with my tangent and my secant. So I would find the measure of angle 2 by taking 1/2 of the measure of arc ABC. All right, cruising along, we'll take a look at theorem 1016. And now we're talking about secants, tangent, and tangent, or 2 tangents intersect at the exterior. So we have 2 major theorems. The first one talked about our secants crossing inside the circle. Now we're talking about things crossing outside the circle. So even though we're talking about secants and tangents in that combination, all we have to remember is, are they crossing inside or outside of the circle? So here, if the if the secants and the tangents or whatever combination we have meet on the outside, then the measure of the angle formed is 1/2 of the difference. Okay, so think subtraction of the measures of the intercepted arcs. All right, so if we look at all three of these situations, notice in all three situations, all of those secants, tangents, or combination thereof are meeting at point A, which is hanging out outside of the circle. And you'll notice that when we have those items drawn, we have two arc pieces. So we have arc DE and we have arc BC. So if we want to find the measure of angle A here, we're going to take the measure of DE and subtract the measure of BC to find the measure of that angle. Same thing happens here in example number 2, but it just so happens that they're wedged up against the tangent. So we're going to say that the measure of angle A, same thing, is DC arcs, the DC arc minus the measure of the BC arc. Okay, and last but not least, if we have two tangents, we still have the same thing. We have two arcs that are formed, that are sectioned off by our tangents here, and my arc BCD minus my arc of BC, if I subtract them, divide by 2, I get the measure of angle A. One thing to keep in mind here is that if we have two tangents, that no matter what, the sum of those two arcs is going to be equal to 360 because we end up dividing it in just two sections. All right, we're going to continue on and see what we understand here with our examples. All right, example number 1, intersecting chords or secants. I'm going to notice right away that if I want to find the measure of x, that's hanging out inside the circle. So the measure of my angle is going to be equal to 1/2 of my two arcs. And I want to make sure that I'm adding those two pieces together. So the arc pieces that are sectioned off, I have arc MP, which is 55 degrees, and I have arc NQ, which is 75 degrees. So the measure of angle X is going to be equal to 1/2 of 130, or 65 degrees for the measure of X. All right, and that's going to tie back with that first theorem for today. Example number 2, this is secants and tangents intersecting on a circle. So here we are asked to find the measure of arc JKL. So starting at J, traveling through L, ending at K. So I want to find the measure of that arc. I notice that HJ is a tangent, JK is a secant ray. So if I want to get the relationship between my angle and my arc, I'm going to multiply that by 2. So the measure of arc JLK is equal to 232 degrees. Cruising along, we have one more to take a look at. And it's talking about a photographer is taking a photo of the Jefferson Memorial in Washington, D.C. from a boat in the tidal basin. The photographer's line of sight are tangent to the memorial points at Q and S. If the camera's viewing angle is 36 degrees, what portion of the memorial will be visible in the photo? All right, so here I notice that my two tangents are meeting outside of the circle, and when we're meeting outside of the circle, I'm talking about the measure of my angle is equal to 1/2 the difference of my two arcs. So the measure of my angle hanging out right here is 36 degrees, and that's going to be equal to 1/2 of the difference between the two arcs. All right, so looking at my picture, I know this is the part of the memorial that I want to figure out how much of that arc I can see. And so that's really what I'm worried about. I'll call that X just for fun. And then I also have this other piece, QSR. Well, I don't know how many degrees that is, but I do know that together these two arc pieces will add up to 360 degrees. So to find the measure of arc QRS, that's going to be 360 minus whatever x is. So I'm going to have 360 minus x for my first arc, and I'm going to subtract that second arc here, which is just x. And from here I have an algebra problem. I take 36 equals 1/2, and if I clean it up, 360 minus x, that's 360 minus 2x. Because it's like a negative 1x minus 1x, in debt $1, in debt another $1, you're in debt $2. All right, there's a couple of different ways to take care of solving this, but I might choose to distribute that 1/2 to both my terms, so giving me 36 equals 1/2 times 360 is 180, and 1/2 times a negative 2x is a negative x. All right, my goal is to get x by itself, so I might choose to subtract 180 on both sides. When I do that, I end up with negative 144 equals negative x. Now keep in mind, even though we can't see it, this is like a negative 1x, and negative 1 times x. So I can choose to divide both sides by negative 1, or multiply both sides by negative 1. Either one will get me there, and I end up with 144 degrees for the measure of arc QS. All right, please take a moment to write a summary reflection, and also you have 2 items to take care of. At this point, you are going to head on over to the Reveal website, which has been linked on Blackboard, and you will complete the check assignment, and that's how I'll be able to check in to see how you understand things. You will also have the digital homework assignment to take care of. Completing these 2 items will account for your attendance for today. And attendance, I need to record by 3 p.m., so those 2 items must be complete by 3 p.m. to have your attendance counted for today. Please make sure you reach out if you have any questions. I'm here to help. I will see you later. Bye.